Did you have any burning questions right off the bat about something maybe we talked about today or the last, although could be from the beginning material that you wanted me to start with? I could do that. Okay. All right. Well, one thing, let me try to share the screen here and actually pull up the PowerPoint because I'll just kind of, let's see. Oh, wait. Let's see if I can never do it this way. Okay. Can you still, whoa. Oh, hey, Jenna. Let me try to do this again. Oh, hey, Joey, I just took him out.
Yeah, you just ate a muffin wrapper. Is that okay?
Yeah.
Wrapper?
Yeah, that's fine.
Stupid.
Sorry, the dog is being a little crazy.
Stop it.
I don't know if you can hear that. He just ate the wrapper from my daughter's muffin, so she had to come in and ask if that's okay. I'm like, he should poop it out, I hope. Okay, so let me just go through and kind of start with, the beginning. And I spend so much time lately talking about the bone names themselves, but just to remember the difference between a blast and an osteocyte and an osteoblast. And the osteoblasts basically model and make the bone, and then ossification. So anything os is pertaining to bone, and ossification is the hardening of the cartilage frame. And let me get out my study guide here too. But I have on the study guide the functions of the bone. So be able to tell me, maybe, usually I ask for 2 or 3 of these. So what are the functions of the bones? Any of these would work. And when I talk about storage, these were like calcium, other minerals, but calcium being the primary one that can be pulled from the bone and can be stored in the bone if there's excess. And then the blood cell formation process is hematopoiesis. So on the study guide, hematopoiesis occurs in the bone marrow. Okay, you don't want to just say the bone because it's specifically in the marrow cavity. And then we talked about understanding the two different, the cancellous versus compact, which compact is always the out. If you cut a bone in half, that's the outer very dense bone. And in the middle, you're going to have the spongy bone, and which is cancellous. Cancellous is up near each epiphysis, the proximal and the distal epiphysis. And it's spiculated, which means kind of looks like these dotted appearance. So on the study guide, I had said another name for spongy bone, which is cancellous bone. And then where do you find the compact bone was another question on my study guide, which that is going to be the cortex, or it's the outer layer of the bone. So that's found around the core is where you find the compact bone. When we talked about what a Haversian canal is, and here it tells you compact bones. Oh, what a cutie. Compact bone is the outer layer of all bones and the shafts of long bones. So whenever you look at a bone, that outer layer is that compact bone. And these Haversian systems these are canals or channels, and if you think about it, it's a bunch of, I guess if you think of it this way, if you had a bunch of like cylinders taped together all in a core. Haversian systems or Haversian channels make up that compact bone. And within that compact bone, you will have the blood vessels, the lymph. So all of that, it's always good to have a study partner, Savannah. So I agree with that. But the Haversian canal, they make up the compact bone and they make up that cortex. So talked about spongy, we talked about the Haversian systems. I didn't, on the study guide, it was number 8, which is where is the periosteum, where is the endosteum located, and what is the function? So that wasn't the greatest question. The function, they are both like a lining or they protect. So the periosteum is a membrane that protects the outer bone, and the endosteum is a membrane that protects and lines the inner part of a bone. You would find endosteum within the medullary cavity, you'd find periosteum around the outside of the bone. And then on that one, so where are they located and where is the function? Now remember, think peri-peel. Peri's like the banana peel, and the banana is the bone. It's that covering. So, and then it is layered with osteoblasts. So they will, they are there to build and protect the bone. So I talked about on number 7, my questions kind of bopped around in order, but what is an osteoblast and an osteocyte? So the difference is the osteoblast is a foundation cell and it is to build bone. And an osteocyte is, basically the mature cell. So that's basically going to create the bone that surrounds those osteoblasts. But an osteocyte is a mature bone cell. An osteoblast is a cell that forms bone. So anytime it's a blast, it's a foundation cell. Okay, and that's the main difference. And I talked about, I didn't ask a question. The Volkmann canals are basically the blood supply, and it allows the blood to get in and out through the Haversian systems. Now, the foramen, I said, what on this question is number 6. It's like I almost went backwards on the study guide, but what is a foramen? But it's basically a hole in a bone. And so something is going to go into it. So that's what a foramen is. It allows either blood supply, lymphatics, or nerves. Now, in the nutrient foramina, that is specifically to let the red blood cells leave the bone marrow and to bring in oxygenated blood. So it's like a channel to go. But anytime foramina, foramen, hole in a bone. And I talked about this is basically, well, let me move forward. Talked about understand how the long bone is formed and what the epiphyseal plate is. So in utero, and then when a puppy is born, well, initially it's all cartilage. At about 30 so days, the skeleton of the fetus begins to ossify. But when they're born, their bone hasn't reached length. So what happens is there is a little bit of a gap, which is a growth plate, which is this epiphyseal plate. And basically, the diaphysis would be kind of here, the epiphysis would kind of be, but they're growing together. And when they grow together, that bone is going to lengthen. So that, I just want you to know the epiphyseal plate is a growth plate and it's layered. The osteoblasts are going to build, basically, if I look here on this slide, it talks about the cartilaginous cells are going to create, osteoblasts are going to form and layer and lengthen that bone. And then when the bone reaches its length, that's when it ossifies. And so the bone, that plate will close. So on here, the picture, if I was, because remember this picture you're going to be responsible for on the test. If you've got the arrow pointing at that little faint line, that is the epiphyseal plate. This one is fused and ossified, so this bone is done growing. And just to review, since this picture, I talked about what is another name for a joint surface and what covers the joint. Anything that is within a joint is called the articular surface. So if you look at this picture on the top, this is the epiphysis, and because there's a bone that would be attached up here, then basically what would happen is that would articulate with another bone up here. So the articular surface is always the part of the bone that is in the joint, and we know it moves. So I have on there, what is another name for a joint surface? That would be articular. Oh, hello, you snuck out.
I did. I'm on my lunch break right now.
Oh, very
Well,
cool.
dinner break.
Oh, good. Well, I'm glad you can join us. I'm recording it anyway, so we started a little late because my dinner went late. So,
Yeah, I've got some frozen pasta for dinner tonight.
It's very yummy. We did bacon, hash brown. My kids wanted breakfast for dinner, so I did eggs, bacon, and hash browns. So I said,
Delicious.
it's easy. I don't.
Oh, yeah.
We're gonna do it. So. Oh, very cool. Well, I was just talking, I'm literally kind of just going through the study guide and hitting some points here. So anytime if I say it's the joint surface, it's the articular surface, it articulates with another bone. And what covers the joint, if you imagine it's like a circle, the lining is the synovial membrane. And that membrane is what creates that synovial fluid. So then when the leg bends, it doesn't rub. It needs that lubricating fluid, okay? And again, bop in if you have a specific question. I can always answer it. I'm just gonna kind of go down this list. 4 bone shapes, I think that's pretty self-explanatory. This was one of your lab exercises. Hopefully you guys got the key I sent out. So those are the 4 kinds. And I have on here number 12, identify the long bone and its structures. Now, I will tell you, sometimes the lines are hard to see, but what this one is the medullary cavity. This is pointing to that black line, and that is the endosteum. Okay, so sometimes people get these 2 arrows confused. This is pointing to that compact bone. This is the spongy or cancellous bone, and then articular cartilage. There would also be, it's not in this picture, there'd be articular cartilage at the bottom here. You have 2 epiphyses, you have proximal and distal, and then the middle is the diaphysis. Okay, and so be able to label those structures, know the 4. What is the bone marrow? It's basically creates the red blood cells, or gives actually all of the blood cells. And for the test you didn't need to know the difference between red or yellow. It's really the hematopoietic tissue, meaning cell formation. And this one I have on number 14, what purpose does a condyle, head, and facet serve on a bone? So basically, if it's the head of the femur or the head of the humerus, it's basically joins with the joint surface to articulate. If we talk about, a facet, or we talk about, they will actually connect. And the process, if a bone has a process, it's a point of muscle attachment. But the muscle narrows to a tendon, and the tendon attaches. So not the direct muscle itself. And then we talked about the head, the facet, and a condyle. Foramen is the hole, and fossa is that depression. And fossas usually muscles will fill in that divot. Now we talked, there is a fossa on the back of the humerus where the olecranon will actually move through. So those are just different areas. If, you know, I ask you, what is the job of these? You've got the articular surface. It's lined with articular cartilage. Anytime you hear condyle, head, facet, those, now facets are, when we talk about the vertebrae hooked together, they're kind of like hooks, but that's where the vertebrae move. It's not a ball and socket. It's like a hook, for lack of a better word. And then a process, all of the names on this slide talk about the different spinous, trochanter, tuberosity, spine. All of those are bony processes, and it's typically where the tendons attach. Because we're going to do muscles last, muscles pull these attachments, and that's how the bones move. So it needs a process or something to latch onto. If we talk about a vertebrae, spinous is the dorsal process. The wings are the transverse processes. And I talked about foramen, so we know that. I typed it in our, oh, and then knowing the difference, what are parts, what's found in the axial skeleton and what's found in the appendicular. But basically the appendicular is any bones of the forelimb or the hind limb. The axial skeleton is the head, vertebrae, the ribs. So the appendages hang off, that's appendicular, and then you have axial. Now, let me look at my sheet here a second. Okay. At the bottom of your study guide that I sent you, you're not gonna have to label a skull, and you're not gonna have to know every bone. I had on there frontal bone, nasal bone, zygomatic, occipital, for the bones of the skull. And remember, the occipital one is on the back. Let me get to this picture. Okay, when we're talking about the skull, we often think about this whole thing, which it is called the skull, but when we're talking about what actually covers and protects the brain is really just this back part. Everything else is part of the facial nasal structure. This is the cranium. So what's actually protecting, we think about from here kind of forward, but the occipital is on the back, has the foramen magnum, and then I talked about knowing, let's see, let me go forward. Sorry, my slides move. The temporal is on the side, but I didn't, in the interest of time, let me get to, this is the picture. Okay, so what we have here, I talked about the frontal bone, which is like our frontal sinus, so it does make up part of the orbit. And then the maxilla, the maxilla up here, mandible down here, and then the nasal bone, which is the long part. Let me see if I can get forward. Here, I didn't talk about knowing any of the inner bones. Okay, so these are the nasal bones that actually literally cover the nasal cavity. And again, the difference between, I want you to know between Dulcio and brachy short, Dulcio is long. I added mesocephalic, which is kind of the middle nose breeds in between that. The lacrimal bone is literally right under the orbit, but the lacrimal duct is where tears come from. So the lacrimal bone is, hopefully you can remember lacrimal meaning tear, and that's near there. And the zygomatic bone. Now right here, it just like looks like a bone, but it's what forms that zygomatic arch. Comes like it's the cheekbone area. And let me go forward. The other thing, and let's see if I mentioned it in a question up here. The inner bones are the turbinates, or the nasal turbinates. That's the only one from that slide that I talked about. Hyoid is the floating bone, but this picture might be good to study. This is what I would expect to see. I was going to write this in an email, but you guys are on the phone call. You will have this image. It will have things labeled with numbers. There will be a word bank underneath, except the word bank will have more words, though you will not be used, but it is a word bank. So you'll literally just have to write number one, whatever I have labeled number one, choose the word, type it in. It'll be similar, the long bone, I don't think I have a word bank for that one, but it'll be a picture with the numbers and you just write the word underneath. So I was probably gonna type that out in an email tonight to just let everybody know. But things that I wanna point out that are hard on this image to see, this point here, this is from, we talked about the ribs and we talked about the sternum, and the manubrium is up here. It's that little point, and the xiphoid is this little point down here. So sometimes that's hard to see on an image. Also, this point here is sometimes difficult, and that's the olecranon. Sometimes people get it confused with the calcaneus. The olecranon is this point of the elbow, and the calcaneus is on the back, and that's the point of the hock. So knowing those two prominences are important. And then remember, I gave you guys the vertebral formula. Okay, and so we talked about the dog and the horse. So we've got C1 and C2. So you need to know what they stand for, what letters stand for. But remember, C1 and C2, I think I have it. For number 19 on the study guide, it said, what are the names of C1 and C2? C1 is the atlas, C2 is the axis. Those are the only two that have names. Oh, there was a good game of this. Yeah, is that the one I sent you, the canine skeleton? It has like a ton of plays. Whenever I go on purpose games, I always look at which one has the most plays. If it only has like 200 plays, it's not. This one, the skeleton I found that I sent you the link, had the most plays. Okay, yep, I think that's the one. Oh, okay. Yeah, I'll have to copy that one. And I'm going to be sending an email later, so I'll copy that so that I can send it to everybody to play. But remember, for the vertebral formula, you have to write it in order, the letter, the number, and then know what the letters stand for. As far as the other thing on this picture, since I'm on it, if you look at this picture, it just calls this the pelvis. I am more specific, and if I'm pointing up here, that is the ilium. That's what you, like when you go down a dog's back, that's the ilium. What you feel back here is the ischium. The pubis is underneath. So the pubis would be like under here. Ischium, that's ilium. Underneath there is the pubis. Sometimes they call it os coxae as the pelvis, but I want you to know the individual names. And then the sacrum is here. So it's kind of hard to see because the wing of the ilium kind of covers, but about L7, S1 is right about the point where that is. And then obviously the amount in the tail is different, but I just said, 20 because it's a range, but it's just kind of depends on the horse, depends on the dog. Carpus front, tarsal back. So I think that's the best I can highlight. And also up here is, there's not a lot labeled on this skull, but that's the zygomatic arch. That little point back there is the occipital protuberance. That's the occipital bone. This would be the mandible. This is the maxilla. But pointed up here, because this picture is lateral, the frontal bone, well, I mean, the frontal is going to be right about here. The nasal bone is going to be right about here. So it's a little bit hard in that image. But again, there will be a word bank. There is not a picture of the horse, but I do want you to be familiar with the names of these bones in the horse. The metacarpal is the cannon. The proximal phalanx is the long pastern. Middle phalanx is short pastern. And distal phalanx is the coffin bone. I don't have it as a question on the study guide. You won't have to label that on a horse, but if I ask you the equivalent name, I want you to be able to tell me. Okay. Let me see. Oh, and something tuber ischiae, sometimes ischium is called tuber ischiae. Ischial tuberosity, it's the ischium, and then that point is the tuberosity of the ischium, which is the point off the back. So that's all that means. So this gives you your the names. Talks about the processes of a vertebrae. I talked about okay. So atlas and axis. Okay. The dog and the horse have 7, so C7. And let me go here. Thoracic, this is where it got different. T13, horse has 18. So actually much more thoracic vertebrae in a horse, but they have a prominent dorsal spinous process, and the lumbar are the ones that have the wide transverse processes to support the abdomen. And this is weird because the dog has 1 more than the horse. The dog has 7 and the horse has 6. But they have a lot more thoracic vertebrae. And then sacral, the dog has 3, the horse has 5, but it is a fused structure. So even though, but for the formula, you need to write 3 or 5, but anatomically, it is a piece altogether. And that is where the ilium fuses, and that's how the back leg is on, stays on the body, forms that sacroiliac joint. And then remember the coccygeal. Remember the spinal cord stops at about L6, L7. It starts to narrow. So you do not have spinal cord really past that point. So not at the sacral, not within the tail. So that's all just vertebrae, no spinal cord. And then pairs of ribs. So however many thoracic vertebrae, there's a pair of ribs per, and then it is a flat bone. It has a little tubercle and a head. It articulates, inhale, exhale. If you imagine this is thoracic vertebrae, and so remember it has a costochondral junction. If it was all bone, your thorax wouldn't expand and contract. The floating rib is that last rib. It doesn't have a connection to the sternum. And so that is called the floating rib. Okay. And then I talked about the manubrium and the xiphoid. So know the difference between the two: sternobrae, vertebrae, costochondral junction, the 2 points of connection. You go back to work. Let me know if you need anything, Ireland.
Okay, yeah, we've seen like 4 emergencies tonight, so I should probably get back in there.
All right. Well, good luck with everything. Thanks for bopping on.
Thank you. Bye.
Bye. Have a good night.
You too. Bye.
Okay. Bye. Okay, so here's the bones of the thoracic limb, which are all on the skeleton. So let's see. Spine of the scapula, and again, this is the fossa, which is that divot where the muscles of the shoulder connect, and then the spine of the scapula for muscle attachment. I also have on here, let me see. So it goes scapula, then the humerus. And remember, if you hear the word condyle versus epicondyle, the condyles are the articular surface, the epicondyles are above, and muscles attached to the epicondyles, but the condyles are like the rollers. Olecranon fossa, that's where the olecranon sits in the back of that humerus. And so if these, it's just important if you know what a fossa is, a condyle, an articular surface, be able to know those names. So it goes humerus, then you have the radius and ulna, which are parallel. The radius weight bears. The ulna is for muscle attachment. There is a gap between those. And then, yes, so back here is that olecranon, which is right here, and shaft in the middle. Then we have the carpus, short bones. They articulate together. We have, now to review, metacarpals, which would be here, which would be the upper part of the paw, are basically numbered medial to lateral, 1, 2, 3, 4, 5. Remember, on the, what I said today was on the back, dogs typically have only 2, 3, 4, 5 metacarpal. Now, they may have this dew claw here, but it means they're missing this part up here. But all I want you to know, metacarpals front, metatarsals back, you number them medial to lateral, and then the digit is pertaining to the whole, like for us to be our whole finger, for the dog it would be the whole toe. In that toe, you have basic proximal, middle, distal phalanx, proximal, middle, distal. And again, if we were to do a declaw on a cat, we're taking off this end part, and they would only then have P1 and P2. So they're abbreviated P and then 1 for proximal, 2 for middle, 3 for distal. So a horse has this bone, that's the long bone, and then the other bones. So let me, let's see, identifying. Okay. Talked about, so I've talked about most of the questions 21 through 24. I've gone through almost every study guide question. Just to review, this is on the horse. This is metacarpal 3, which is the cannon bone. Metacarpals 2 and 4 were the splint bone. That was an exercise in the lab book. So hopefully you didn't have any questions on that. And then we've got no 1 and no 5 on the horse. So don't have to know the cow limbs. Let me do something. Let me skip because it's so. Hopefully you can still see this slide, but this gives you all the bones of the pelvic limb from proximal to distal. One thing to stress here on the pelvis, I just explained, you have ilium, ischium is down here, pubis is in the middle between the obturator foramen, and that's where it fused. And that is a type of that's a cartilaginous joint. So the three joints were the fibrous, cartilaginous, synovial. Fibrous are in the skull, they fuse, they do not move. Cartilaginous joints are where two bones come together with cartilage, like the mandibular symphysis, the pubic symphysis allow a little rocking, and then synovial are like your elbow, shoulder, hip, where they are freely movable. And a synovial joint creates that synovial fluid. A fibrous joint's not going to have fluid. A cartilaginous joint is not going to have fluid. But the other joints will, or the synovial joints will have fluid. Let's see here. And the patella is the only sesamoid bone that I had for you to know, which is found in the stifle. So that's the only one you had to know for the test. The one thing, let me get this big a second. On the image of the skeleton, which was lateral, this point back here is the calcanean tuberosity, which is sticking off the back, which forms the hock. So the hock, that calcanean tuberosity is part of the, attached to the Achilles tendon. So that's what we're looking at there. Let's see. What other questions did you have? This hits the majority of the study guide. Was there anything in the homework or something we didn't cover in lecture? No, we're good.
I think we're good, or at least I am.
Jonathan,
Yeah, I just
Jenna?
kind of wanted to make sure like I was all good. I didn't want to just miss out an opportunity for like extra.
Oh, certainly. You're good. Yeah, no, that's why I did it. Well, I'm going to, if someone wasn't able to join, as soon as I end this, I'm going to do the convert it and I'll send the link. I'll send out the vertebral formula again, just to make sure everybody has it. What else did I say I was going to send out?
Yeah, because like I knew most of the bones because I had taken anatomy and physiology in high school,
Mhm.
but I wanted to make sure because I had never learned the bones of dogs or like other animals. So I just wanted to like be extra positive that I like knew what I was learning.
Oh, for sure. I'm kind of glad that they have, the same names. I always kind of talk about us. I'm like, I know we're learning dogs, but sometimes if you can relate it to yourself, it makes more sense. Oh, study buddy.
Yeah, her name is Zenna. She's very protective of the house. She's a pit bull mix.
Oh, she's cute.
Mm-hmm.
She looks like she's ready for bed, though.
Yeah, she's kind of tired. She has arthritis on her back legs, so she's kind of really she wasn't feeling too well today, and she has a bunch of like tumors on her back and like on her legs and stuff. So
Poor thing.
yeah, but it's just too expensive to take them off. But she's living a happy life. She loves to chew on her toys and stuff.
Good. Well, good for her. She looks. Oh my God, she's so cute.
Yeah.
Yeah. I think my dog's out there probably cuddling, watching the movies. Cuddle time for him. Well, I'll send this out so in case you want to review again, or thanks for joining me, and let someone know that I'll be posting this link here soon. And it'll open up, I'll open up the test at 9:50. I think I'll give you 3 hours to, or well, you have to, a 3-hour window and then about 90 minutes to take the test. So should have plenty of time. All right. Well, you guys have a good night. Thanks for joining me.
Yes,
Yeah,
thank
thank
you for
you.
having us.
Oh yeah. Now I didn't want to rush it, so I figured, you know what, give everyone a little time to study and then reconvene before bedtime. And
Yeah.
it's a lot of stuff, so I don't mind.
All right.
right.
Well,
All right. Well, you guys have a good night, and I will. Well, I won't see you guys tomorrow, but I'll be in touch, and you guys will do great.
yeah.
All right,
Thank you.
thanks.
Thank you so much.
You're welcome.
Bye.
Good night.
Bye.
Bye.